Okay, in this video, I'm going to cover subtraction. And I'm going to show 4 different strategies you can use to subtract. I'd like to separate these into 2 schools of thought. So the first one would be finding the difference. Okay, and the strategies I'm going to show you for finding the difference, one is called counting up. And the second one is using a number line. The second school of thought, as far as subtraction that I'm aware of, is to take away, or taking away. We will review the standard algorithm, the strategy that most people are aware of and were taught. And the second strategy, as far as taking away, that we'll cover is with the base 10. Okay, let's go ahead and start here first with counting up. And then I'll go ahead and show you how to do it, and then we'll talk a little bit, or rather, I'll go ahead and go over some of the positives that I feel are beneficial for this strategy. Okay, counting up. What is the objective of this strategy? Well, the objective of this strategy is to count from the smallest number to the highest number to find the difference. Count up from the smallest number, or the minimum, to the highest number, which is the maximum, to find the difference. Between the two numbers. Okay. All right. This is a weird strategy if you're not familiar with it. And I remember the first time I looked at it, I was really kind of taken aback with how odd it was, or just the way it looked, basically. So let's go ahead and just jump right into it and look at an example. I'm going to take something very simple, say something like 23 minus 7, something like that. Okay. What we're actually going to do is we're going to use addition to solve a subtraction problem. That's one of the things that's a little bit confusing about this strategy. So I'm going to start with the smallest number, which is 7, and I'm going to put it right underneath this line here. And then I'm going to add numbers to 7 to get up to 23. I can use whichever numbers I feel comfortable with. I prefer to use numbers that will give me base 10, or to get me to the nearest 10 or value of 5s, because it's easier for me to add from that. So let's go and take a look what that would look like. So I'm going to add 3 to 7 to get to 10. What I like to do, and what I've taught my students, is to circle essentially what are partial sums or part of the answer. So now maybe I want to add another 10 here. Now I'm at 20. Oops, I actually circled the wrong number. Okay, now the next thing I want to do, because I know I'm trying to get to 23, is I'm going to add 3 here. Now I'm at 23. So these numbers that I've circled, I want to add them together. I tend to start with the higher number first, so like maybe 10. Check it off so you don't lose it. 3. And then I have another 3 here. And when I add that all together, I get 16. And that's my answer. Okay? So let's go ahead and review the way that looked. So I'm doing 23 minus 7. I take the smallest number and I'm trying to add to get to the highest number. So I add 3 first, which makes it easier for me because now I'm at a multiple of 10. So 7 plus 3 is 10, and then I'm going to add another 10 to get to 20. Then I'm going to add a 3 to get to 23. I've circled each of these numbers that I added onto it. Those are what are considered partial sums. So now I'm going to add those all together. 10 plus 3 equals 16. Okay, so I know that 23 minus 7 equals 16. Another beneficial aspect of this strategy is that I don't have to borrow. If you noticed, in this case I would have had to borrow because 7 is going to be greater than 3, and we know that whenever, and we'll get into this later in this video, this is a bigger bottom, so we would have to have borrowed from the tens place. Okay. Another thing I want to point out here is that these numbers that we're dealing with, 7 for example, is what we started with, and we had to get to 23. All the numbers that we added that I circled are going to be considered your partial sums. Let's look at some other examples. Okay, so that was a bit of a simple one. So let's kind of ramp it up a little bit, not too much at first. So 58, let's say minus 12. Of course, most people can look at that and understand what that is immediately, and that's fine. But let's go ahead and start from 12, which is the smallest number. Okay, some kids like to add 10 to it, and that's fine. So now we're at 22. Don't forget to consider what you're adding to the number, or else you're going to run into some problems. Okay, so 22. Maybe I'm getting a little bit more advanced and I realize I can add 20. I'm getting closer to 58 now. 22 plus 20 equals 42. Okay, now I'm going to add another 10. Just kind of pretending like I'm a kid. This is kind of the way most kids work when they're just beginning. So 42 plus 10 equals 52. And then I know if I add another 6 here, I'm going to get to 58. Okay, in this case, what I've done is I've gone from 12, right, the minimum or the smallest number, to 58, which is the maximum or the highest number. I've circled all of my partial sums. I almost said partial products. That's another video. Okay, 20. It's easier for me if I just add the highest numbers first. So 10, checking off each one. It's easy to make a mistake actually with this, and 6. 20 plus 10 is 40, plus 6 is 46. And that's going to be my answer. So I know that 58 minus 12 equals 46. People at home might be looking at this and saying, well, why bother when all I have to do is just subtract? Well, like I said before, in this other example, we didn't have to borrow at all. And borrowing is tough for kids. I mean, they can obviously understand it, but it does take time and mistakes will be made with borrowing. And for kids that are around 8 and 9, especially like third grade kids like I teach, it's going to be a bit of a difficult, it's going to be difficult for them conceptually at first to be able to borrow. Okay, 58 minus 12 is 46. I started at the minimum. I got to the maximum. I added these numbers. And it shows the flexibility with the numbers that you can add to it. I mean, I could have just done, added 40 at first and then added 6. Or I could have just added 46 to 12 to get to 58. That's another thing that I like about this strategy is it does create flexibility with numbers. Okay, let's look at some more examples. Let's go into the hundreds. So I'm going to do 127 minus, say, 85. All right. Start with 85, which is our minimum, of course. I'm going to add 15 to get to 100. This is called a landmark number, and it's good to try to add to numbers like this because it makes it easier to make another move, another addition move to get to the number you're trying to get to. So now I'm going to add 27 because obviously I know that 100 plus 27 equals 127. I circle my partial sums. Okay. I have 27, which I prefer to put the highest number on top, like I've said, and 15. Now I'm going to add those together, and we have 42. Oops, what in the world did I just do? No, that's right. Looked weird for a second. Okay, so anyhow, let me double check that to make sure that that's correct. Use my calculator. All right, so 127 minus 85 equals 42. And like, I said yesterday with kids, allow them to use a calculator. I will repeat myself, and being a teacher so long, you do repeat yourself quite often, and allow them to explore a calculator. It's okay. They'll use it as a learning tool eventually. Okay, let's move to some bigger and higher numbers. Let's just go into the thousands. So we'll do 1,000, 236 minus, let's see, how about 647? Something weird. Okay, so what I'm going to do is I'm going to go from 647. I want to try to get to 700 if I possibly can. That way, it's a landmark number that I can make a big jump off of. So I'm going to add 53 to 647. Okay, so now I'm at 700. Okay, now what I can do is I recognize I can actually add 500 to 700 to get to 1,200. If I recognize that, why not just add another 536 to it? add that. Now I actually got to the number 1,236. Okay. What did I do here? This looks weird. Okay, well, it looks like I got to 700, and then I just added another partial sum to it. Okay. So 1,236 is what I was getting to. And we'll double check this, of course. I apologize, I'm a little bit groggy today. My sleep's been off since school's been closed because of what's going on in the world with the virus and things like that. So I'm a little bit off when it comes to sleep. Okay, so let's go ahead and add these together. That was it. That's why it looks so weird. Don't be afraid to make mistakes. When it comes to math, it's all about, making mistakes and just getting messy with it. I love when my kids can, or my students can actually find mistakes that I make. Sometimes, I do make mistakes like you see right here, but it's all just about a thought process and being able to, critically think about what you're doing. That's the most important thing. So 536 plus 53 589. So 1,236 minus 647 equals 589. Let's go ahead and take a look to see if that's the case. I can tell I'm a little off my game today, but that's fine. 36 minus 647 equals 589. So that is the counting up strategy. I love this strategy. If you get good at this strategy, you can do it mentally. And there's times when I'll just be driving around or just be doing mundane things, and I'll pose a problem like this in my brain and see if I can solve it. And usually I do pretty well, especially if I keep in mind these landmark numbers that I'm trying to get to. Trying to get to the nearest tens, multiple of 10 or multiple of hundreds. That's really going to be advantageous to me. Okay, so let's go ahead and take a look real quick at the counting up strategy. It's not going to be everyone's cup of tea. It's going to look weird, to be able to add on to something to solve a subtraction problem. For most people, it's counterintuitive. I know it was for me when I was learning how to do it, especially when I first saw it on paper. It was really odd looking. Okay, so counting up. These are the advantages, in my opinion, of counting up. The very first thing, of course, is going to be that you don't have to borrow. No borrowing. Flexibility with numbers, which is huge. Most of the time we're not walking around with paper and pencil or a, dry erase board and some dry erase markers. Okay. Another thing too is I think that it increases your number sense. And it's possible to do it mentally. As long as you can keep those partial sums in mind and then add them together later, then you're good to go, basically. Okay, awesome. Okay, the next thing we're going to take a look at is how to do subtraction on a number line. And it's also going to be finding the difference between the two numbers. I'm going to use the same numbers that I did here in this demonstration. When you're practicing at home and you're really working on your mathematics and becoming more fluent with numbers, I really think it's important to try different strategies with the same numbers. I think that's an intelligent way to approach it. All right, so let's take a look. Okay, so this is going to be our second strategy, and this is going to be on the number line, subtraction with the number line. All right, so let's talk about the objective. Is to find the difference between the minimum and maximum numbers. Okay, and we know, of course, that the minimum is going to be the smallest or the least. And we know that the maximum is going to be the most or the greatest. Okay. Now, one thing that's really cool about the number line, and a lot of people don't like it, I know, especially I get a lot of feedback from parents that many of them really don't care for the number line. They don't really understand sort of how to use it well. So that's why I'm doing these demonstrations, to give you some examples of how to do this. Okay, so let's go ahead and use the same one that we did here, 23 minus 7. Obviously we know what the answer is, but let's see if we can prove it. Okay, we are going to do these double arrowheads once again. Okay, now unlike adding on a number line, subtracting on a number line, I'm actually going to put both of the numbers on there underneath these hash marks. And all I want to do is just go ahead and make some jumps, what are called jumps, from 7 to 23, or with this strategy, I can actually go backwards. And I'll show you both of those ways. Okay, so let's take a look now at this one. Okay, what I'd like to do here is I'd like to add 3 to get to 10. Maybe add another 10 to get to 20. And then maybe add another 3 to get to 23. And I actually forgot to write the problem here, and that's fine. Okay, so these jumps that I just made right here are what's going to be your answer. We're just going to add all those jumps up. Okay, so 3 plus 10 is 13. 13 plus 3 is going to be 16. So I know that 23 minus 7 equals 16. Notice once again, we don't have to borrow. What a wonderful thing. Anytime, in my opinion, I can get away from borrowing, I'm good to go. I don't really care for borrowing so much, but obviously we can get the answer correct by borrowing. Okay, so let's take a look at the same number, except what we're going to do is go backwards instead. Or rather, the same problem. So start at 7. Put 23 there. Okay, so let's go backwards. So some kids, of course, you know, you're teaching them how to do a subtraction problem, and they're going to not want to add to it, okay, because they've been taught that subtraction means to be able to take away, and they have a good point. So going back on the number line is a preference for some children. So what I'm going to do is I'm going to take 3 away from here. Or maybe let's just do something different. Let's take 10 away. Some kids love to do that. So now I'm at 13. Okay. Now what I want to do is maybe take another 3 away. Don't worry about the size of the jumps, especially kids that are like 3rd grade. You know, at first they're not going to, they want the size of the jumps sort of to indicate how much the value of the jump is, but it's really not that important for this, not for this practice. So 13 minus 3 is 10. Okay. And now I just want to take another 3 away. And now I'm at 7. Another thing that confuses some kids with this strategy of going backwards is we use a subtraction symbol and we follow the number line. So 23 minus 10 is 13. 13 minus 3 is 10. 10 minus 3 is 7. So we use the symbol to go back, but then we have to add it afterwards. Okay, we have to add the sum. So 10 plus 3 equals 16. That can be a little bit confusing to some kids. But once they get a little bit more flexible with their numbers and their understanding, okay, then they can go forwards on the number line by adding onto it, going this way, or they can subtract on the number line going this way. Some kids I know like to draw like a little arrow here, you know, so it shows in their brain that they're going this way. When they go back, I've seen kids do this. That's not a bad strategy to use either. The most important thing to remember is that you're just trying to find the difference between the number, that's all. The two numbers, that's all. Okay. All right, let's look at some more examples and let's just continue to practice. I put the paper this way instead. Save some paper. Okay, so the second one I want to do, I don't want to use the same numbers. That's kind of boring. Let's use a 2-digit number minus a 2-digit number. In this case, I don't want to use the same numbers, so because some of you guys already know the answers. So we'll just do 67 minus, say, 49. Okay. Again, double arrowheads. Smallest number or minimum. Largest number or maximum. Okay. We're going to go forward. We're going to add on. I'm going to add 1 here to get to 50. A good landmark number right there. Maybe I want to add another 10 to get to 60. Add another 7 to get to 67. These numbers are your partial sums, and when added together, they'll show the difference between the two numbers. 7 plus 10 is 17 plus 1 is 18. 17 plus 1 equals 18. Okay, let's take a look at this same example, but going backwards. 49, 67, okay. Now, kids are really clever with being able to do this. So a lot of them would just take away 7 right away to get to 60. It's a clever way to do that. Then they might even tell you, take another 10 to get to 50 now. And then go ahead and take another 1. Take a 1 away to get to 49. If you actually compare these two number lines, take a look at what it almost mirrors itself in the same instance there. If you take a look, just going forwards and backwards. That's all. Okay. All right. So we have 7 plus 10 plus 1 equals 18. Same answer. Okay. The difference. Okay, let's take a look at an example here of higher numbers. So we'll get into the hundreds now. Let's just say 132 minus, how about 73? Okay. Okay. Figured it was probably best for me just to be quiet there for a moment since I'm rambling so much. But you get the idea. Sometimes it's really good for kids just to show them the process without even talking or discussing the process as you go along with them. That way they can kind of try to, and then afterwards you want to question them. So ask them, okay, why did I do this move here? Why was that a good strategy to use? Why did I decide to take 20 away here? Why would it be a good idea to take away 7? How can I find the difference between these two numbers by going forwards and backwards? Which one do you prefer? Ask your kids questions like that. It's really going to help them to have what's called metacognition, where they're thinking about their own thinking, and they start to give you some really surprising answers. You're going to see just how intelligent your children really truly are with understanding mathematics. It's a little bit different than, sometimes they go home with homework that, they can't really explain very well, and then they look to you for help, and you don't know what the strategy is that the teacher thought. But asking them questions like I just posed right there, well, why did you decide to do this? What did your teacher show you to do first? Is this a good idea to take 20 away right here? Would it have been actually better if I had just taken 27 and just had done a bigger jump just right to the number? You know, is it possible for me just to go from 73 and make a huge jump all the way to 132? Absolutely it is. Absolutely it is. And you'll find that when your kids are getting more advanced with this type of strategy, they will start to make less jumps. When you see your kid making less jumps on the number line, you know that they're starting to get better at it. The more jumps that they do, you know, they're just beginning and they're just practicing. Okay, let's look at an example in the thousands. Okay, let's say something like, make it a little bit more interesting, 470 minus, let's do something like 2,320. This one doesn't require borrowing, of course, but let's go ahead and take a look. $2,320, trying to get to 6,470. Okay. First thing I want to do, I'm looking at that 20 right there. I might want to add 80 to it, but you know what? If I add 80 to it, that will get me to 2,400. If I add another 600 to that, I can just get to 2,000, actually 3,000 is what I'm thinking. Okay, so again, I'm going to add 680 right there. Now I'm at 3,000. Look at that advanced jump right there. Now all I have to do is just jump like this. Go straight there. Plus 3,470. Look at that. Okay, so 2 jumps. I used a landmark number here, and then I just added the difference here to get to 6,470. Okay, let's see if I did that well. It looks good. And of course, we're going to go ahead and we're going to take a look at that with the calculator afterwards. So, I'm not adding that straight off my head right now, but what I can do is I can just add those partial sums together to see if I can solve that. 3,470 plus 680. Okay, you know what I want to do? I want to do partial sums instead. So 3,000, 1,000, 150, and then if I add that together, I get 4,150. Okay. All right, so it looks good. Let me double check with my calculator. 6,470 minus 2,320 equals 4,150. Okay, let's go back on the number line with that. $6,470, 2,320. Okay, I want to try something a little bit different. I want to take 470 away so I can get to 6,000, right? Then I'm going to want to subtract 3,000 here. Well, that's what I want to do. You can do whatever you want. You can go ahead and go by ones if you want to. It might take you a lot of paper, but you'll get there eventually. Okay, so I want to take away 600 to get to 2,400. Now I'm going to take away 80 to get to 2,320. All right. Notice once again, the more jumps that you do, actually, the more likely you are to get the problem incorrect, because you have to add more numbers with your partial sums in the end, okay? So just keep that in mind. I'm going to take this 3,000 here, because it's the biggest number. It's easier for me to add that way. 470. Oops, 600. I can tell that I have not been getting good sleep lately, but that's okay. Many of us probably aren't getting the best of rest right now. Got a lot on our minds, but you know, staying focused and staying disciplined is important, even through the toughest of times. So now 3,000, I'm going to use my partial sums once again because it's easier for me. 400 plus 600 is 1,000. 70 plus 80 equals 150. Now if I add that down, 4,150. Okay. All right, so you're able to see that, you know, I used going back with the number line and going forward on the number line as well. Using addition to solve a subtraction problem. It's very interesting to do that. Okay, and that's how you solve subtraction problems on a number line. Okay. Advantages of using a number line for subtraction. Okay, there's a couple. The one thing that I love the most is that the flexibility with numbers. The kid that's the most advanced in class and the kid who's not can both do this. They might be using chunking different numbers to get to the actual answer, but it's doable for all. Maybe I'll actually put that, doable for all. Okay. No borrowing. That's one of my big things, especially when teaching children, younger children, to be able to subtract. If you can get away from borrowing, do it. I have no problem with that. This is a strategy you can use with your kid too. You know, you can ask them, okay, so what were the things that you liked about the number line? And what were some things that you did not like about the number line? Make a little T-chart right here. Right, get them thinking about this. You know, when they're thinking about their preferences, then that means that they're understanding the strategy so much better. And they're using what I discussed earlier, that metacognition. Okay, so I'm going to show you what I like. Obviously, you can tell by now, no borrowing. Okay. What I didn't like about it is, okay, can make mistakes. When you're working with too many numbers. What I like about it is flexibility with numbers. Gives you a good number sense. And you don't have to go back and forth. That's basically the only thing I really don't like about it. Strengthens your number sense. And you can do it mentally. Remember that too. So it's mentally doable. Okay. All right. So those are some examples there of things that you can do when you're working with your kid at home. Make a little T-chart like this. Make it interesting for them. Ask them questions. So it's more than just, you know, the procedures and the method behind it. It's also, you know, getting inside of your kid's head in a sense. That's the best teaching, and that's when you really get to understand them, you know, not so much as your kids, but as learners. And that is something that, you know, parents are unfortunately going to have to really, you know, work with their kids nowadays because the schools are closed. Is, you know, what is my child like as a learner? And you're going to find some interesting things. I guarantee it. I guarantee. You probably already know. But there's going to be mysteries that are going to be there as far as just their thought processes, their cognition goes with learning. Okay. So the next thing we're going to do is the standard algorithm. This is anytime we talk about standard algorithm, all right, and if you saw my video ways to add, then you know the algorithm that was oops. You know that the algorithm just means basically what most people can do. Basically, it was the way I was taught. I didn't know a lot of different strategies. It wasn't until I became a teacher that I learned the number line and counting up and base 10 and things like that. Okay, so let's take a look at the standard algorithm. I know this isn't the most high tech, but you know what? It doesn't have to be. It's a learning process for me too. Maybe soon enough I'll have all the fancy little jingles and emojis flying around the video, but for now this is fine. All right. The objective of the standard algorithm is to take away the maximum from the minimum. Okay. Now, you may think that it's easy for your kid to do the standard algorithm, but in some ways it's really not. I know that, you know, even with my students, some of them were just learning how to do the standard algorithm, and it took a couple lessons for most of them to become pretty proficient at it. So I'm going to use a little trick when we have to borrow, and I hope that you remember this. because I guarantee if you're one of my students that you do. It's bigger, bottom, better, borrow. Okay. I can't emphasize how important this is. Bigger, bottom, better, borrow. And you can even say like bigger bottom, better borrow. Okay. It's corny. All right, so let's go ahead and work with, some basic subtraction. So we'll do 15 minus 5. Something easy. Okay. Now, a beginner, right? Especially if they don't, it's difficult for them to understand their place values. Okay, remember this if you saw my video with, doing the place values there. We're going to take away, so 5, take away 5 is 0. 1, take away nothing, obviously, is going to be 1. It's fine to say it like this with a beginner, no problem. What I prefer to do with my students, even with a very simple problem like this, is to have them, not all the time, especially if they're struggling, but to have them actually say the place values. So 5 minus 5 is 0. 10 minus nothing is 10. Or 10 minus 0 is 10. In fact, what I do is I teach my students that 0 doesn't mean nothing. It just means emptiness. There's nothing really there. This is something you can do, a strategy you can do with your kid, is to show them that there is emptiness there. Okay, but notice I said it by the place value. I didn't say, 1 minus 0 is 1 like I did here with a more basic problem. Okay, I'm trying to build their number sense by saying things like this. All right, let's move on to something more difficult. We'll do some 2-digit numbers here. Okay. You know that your kid is having a hard time borrowing if they start doing stuff like this, which is very common. Very common. Okay? If they do this, you know that they don't understand the idea of borrowing yet, or they simply just made a mistake. Okay, even the most advanced kids, when it comes to borrowing, will make mistakes with the standard algorithm. Okay. What I call this is a common mistake. In the classroom, if I pose a problem like this and I circulate around my students, meaning I, go by their desks and I see the different various answers that they're giving me, this is going to be a common mistake. Maybe say 3 or 4 kids out of 15 might make that mistake. And what you want to do as a teacher is discuss this. Why would most people think that this would be 13? That way it actually allows your kid to think about the mistake that they made and to correct it on their own. Okay. In this case, we have a bigger bottom. So I suggest you do a couple things, okay, when the kid is learning. Maybe highlight the 6 so it really stands out, okay. Realize that they're borrowing over here. Drop this number down a little bit. Sometimes if it's just hanging out here, it's confusing to a kid. They don't see that as 13. But if you drop it just a little bit, they kind of see, oh yeah, look at, there's a 13 there. So now 13 minus 6 is going to be 7, and 1 minus 1 is nothing. So, you know, when kids learn, of course, at first they might think, do I put a 0 here? Yeah, don't discourage them for, you know, putting a 0 there at first. It's fine. And again, even when I practice the most simplest of problems, I am going to try to stretch it out where I'm thinking about it as by the place value. Okay, so I have a bigger bottom here, so I'm going to borrow from the 10s. So I'm going to borrow a 10 from the 20. 13 minus 6 is 7. 10 minus 10 is nothing. The answer is 7. So 23 minus 16 equals 7. Okay, let's continue. Let's move into the hundreds. And again, I'm not really going into, you know, astronomical numbers because, you know, this is more geared for kids in third grade, maybe fourth and fifth. All right. And my multiplication and my division instruction, those videos will be a little bit more appropriate, I think, for fifth graders because it shows some strategies that will be very challenging for them. You know, this is perfect for, you know, like a third grade kid, you know, even a fourth grade kid, you know, but obviously fifth graders, this is going to be a little bit easy for them, and that's fine for most of them, at least. Let me get away from that. 4, and then I'll just, yeah, it's fine. If you don't have a highlighter, okay, identify the biggest number anyway on the bottom. So I know that, you know, I know that 2 is not going to be bigger than 5, but I know that 8 is definitely bigger than 2, and I know that 1 is not bigger than 4. It's okay for a kid to think that way. Ones, tens, hundreds. 5 minus 2 is 3. Okay. I have to borrow here. Scratch out the 4, make that a 3. Okay, put the 1 over here. 12 minus 8 is 4. 3 minus 1 is 2. 243. Five minus 2 is going to be 3. Bigger bottom, better borrow. I'm going to borrow 100 here in the tens place. 120 minus 80 is 40. 300 minus 100 is 200. I remember when I was a kid, and this is basically the only strategy I knew as far as, you know, subtraction, the standard subtraction algorithm, and you know, we didn't really know what the number was until we actually found the answer, and then we said, oh, it's 243, because the whole time we were thinking this is a 4 and a 2, but obviously it's not going to really help your place value sense or your number sense. So that's why I encourage, you know, make that transition eventually with your child to think about it by the place value and have them repeat it back that way. Some kids can definitely do that. I know that there's a good percentage of my third graders that can say it this way. Not all of them. You know, and sometimes it gets a little bit tedious. You get lazy and want to come back to this. That's fine. Whatever. Okay, let's look at something in the thousands place. Why do I keep thinking that this is 1? I need to start stepping up my number game here. Okay. Okay, in this case, obviously we have, two bigger bottoms at first glance. Okay, so here I have a bigger bottom here. I'm going to use my highlighter. If you have a highlighter, use it. I have a bigger 10, bigger hundreds. Okay. Ones. If this helps your kid, cool. One thing that I like about this is that it actually helps them stack the numbers straight. A lot of kids, and you probably know this as parents, and when you see their homework, sometimes, they're writing the numbers weird. Like, some kids, I shouldn't say weird, that's not right, but just oddly, they might actually put like, their 4 is here, and then their 6, and their 8, and then their 3 is here, and then you've got some problems, because they're not, it's more difficult for them to subtract across in ways like that. But when you're just teaching them initially, this isn't a bad idea here. Stack it. Teach them to keep it straight. 5 minus 4 is 1. Okay. Some kids are going to be a little bit thrown off here when you have to borrow. They don't know, okay, they want to go here. They know they have to borrow from here, but they don't realize they have to go all the way to the thousands place. And that's fine. Show them. Now we have 13 minus 6 is going to be 7. 11 minus 8 is 3. 4 minus 3 is 1. 1,371. Okay, remember, don't hesitate to allow your child to check their answer with a calculator. When they get it right, they're so excited. Especially when you're working with bigger numbers. Something like, 15 minus 5, obviously you don't need a calculator. But when you work with higher numbers, definitely use it. Okay. Five minus 4 is 1. Bigger bottom, better borrow. Bigger bottom, better borrow. I'm going to borrow 1,000 here, and that's going to be 1,200 because that's 12 hundreds in the hundreds place. I'm going to borrow 100 in the tens now. So now I have 130 minus 60, which equals 70. I have 1,100 minus 800, which is going to equal 300. And I'm going to have 4,000 minus 3,000, which equals 1,000. 1,371. Awesome. And that's about as far as we're going to take it. Excuse me. I think that, even though these are, some basic examples, I think that there's a lot of information there as far as to help you understand, why your child is thinking a certain way when they're trying the standard subtraction algorithm. Okay, so let's go ahead and take a look here. All right, let's just do plus. The things that I like about it, because obviously, you could probably tell that it's not my favorite strategy to use, but hey, it's the strategy that most of us learn to do, and it definitely has its value. So a couple things here that I like about it is it's common to most people. Okay. And, obviously if you know the procedures, the steps, of the standard subtraction algorithm, then you can find the answer, okay? You know, okay, so once you understand the steps, okay, you're good. All right, so that's the standard algorithm, and obviously there's going to be a lot of different videos online that you can watch. Plus, you know, I know that most of the parents out there know how to do this. Okay. Okay, the next thing we're going to do is subtraction with the base 10. If you watch my video ways to add, then you got an opportunity to see what the symbols mean. Okay, so subtraction, base 10. Okay, so the first thing, let's review if you didn't see this yesterday. Okay, this symbol means 1,000. It's called a big cube. If you have what are called manipulatives, base 10 blocks, use them. I think it's a great thing to do. You can order those online. They are a little bit expensive, or go to an educational store near you. This is called a flat, and a flat is equal to 100. Okay. And then we have a long, and we know that a long equals 10. And we have a small cube, which equals 1. Okay. Take a look at that for a moment. All right, so let's go ahead and see ways that we can subtract with base 10. Some kids love to do this, especially those visual learners. Those visual learners just absolutely just enjoy this strategy so much. Okay. Base 10. What's the objective? To visually represent a subtraction problem Okay, and this is takeaway as well. Remember we talked about those two different schools of thought where, you know, finding the difference would be more like counting up and using a number line, whereas takeaway would be more like the standard subtraction algorithm and base 10. Okay, so let's go ahead and start off with a simple problem. We'll start off with, and you always want to do that, especially when you're, you know, just learning something. Let's take like 25 minus 13. Something simple that we don't necessarily have to, you know, borrow. And it actually might be an advantage if you just do it like this, write it linearly, or in a line, or what's called horizontally instead of actually stacking it. That's not a bad idea. So now I'm going to use two longs, right? 10, 20. That represents this 20 here. And then I'm going to take 5 small cubes. And then I'm going to subtract that from 13, which is 1 long and 3 small cubes. Okay. What you want to do with this strategy, and I should not have used a Sharpie actually, but that's fine. Okay. What you want to do now is you just want to take away from one side. Okay, you want to make sure that you show what's the imbalance on either side of the subtraction symbol. Okay, so what I'm going to do here is I'm going to take this. I'm going to take away that long here. What you do on one side, you have to do on the other. Okay, I'm going to take away that long. Notice that I'm going back and forth for each one. You want to do this for, kids that are just learning this. They get a little bit shaky there. They want to, try to take away 2 at a time here, 3 at a time here. But then they might not take 3 at a time on this side or whatever it is. So, excuse me, when you're first beginning, you want to try to teach them, to take 1 from each side equally. Okay, notice I don't have anything here anymore. Okay, but what I have on this side is I have 1 10 and I have 2 1s, and that equals 12. (10 plus 1 plus 1 equals 12. 25 minus 13 equals 12. It's fun. Kids really, they really like this strategy. It's not for some kids. Some kids don't like it, but some kids really get into it. And even the ones that say they don't like it, they kind of do in some ways. All right. So let's look at more problems here. Let's do a problem that is, I'm just gonna use a Sharpie, whatever. 36 minus 18. Bigger bottom, better borrow, right? Okay. So let's see what happens in that case. 3 longs. 10, 20, 30 minus. I can tell my brain's all over the map today. It's all right though. Okay, so I have 30 here, and then I have to have 6 1s. If you watched my video on ways to add, when you're doing base 10, it's a good idea to kind of stack these in columns of 5 or columns of 10s, your 1s. That helps to organize it for the kid. So now I have 3 10s, which is 30. I have 5 and 1 extra small cube, which equals 6, 36. Okay, on this side, I'm going to take 18. 1, 2, 3, 4, 5, 6, 7, 8. Organize myself here a little bit. Okay, so remember what we did for this example on top, okay? We have to take away 1 from each side equally, an equal amount from each side, okay? The first thing that pops up in my head is that I see a long here that I want to take away, and I see a long here that I want to take away. Okay, then I see that I have 5 1s here and 5 1s here that I want to take away. Okay, now I'm running into a little bit of trouble, right? Because I have 1 1 here, and I have 3 1s here. Some kids don't know what to do in this case. Ask your kid if they know what to do in this case. I guarantee they're probably going to be able to tell you. Okay, in this case, what I would do is what's called decomposing. So I'm going to actually break down this 10, this long, into 10 small cubes. So what I do is I take this, and then I make this 10 small cubes. 1, 2, 3, 4, 5, oops, that's okay, 6, 7, 8, 9, 10. Didn't want to lose count there. So now I had 1 cube there, and then I added another 10 small cubes from my long. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. It's a process. I've taken everything from this side, so I've taken all my 18 completely away. All right, so what am I left with now? I'm left with 110 and 1, 2, 3, 4, 5, 6, 7, 8. Okay, so 18. That's how we talk in the southwestern part of the United States sometimes. Sometimes we say lefted. And it's all good because we can still do math. All right. Anyhow, let's move on. Remember the move here with that 10 to turn that long into 10 small cubes is called decomposing. And no, it's not like the other type of decomposing. It just means breaking that number apart. Okay. Let's continue. Let's move into the hundreds now. We'll do 124. Why do I keep doing 100? No wonder I can't, I'm not a millionaire by now thinking with low numbers like that, right? Think big kids. All right, so let's think here. So now I'm going to have 2 flats for my 200. Then I'm going to have 2 longs. I'm going to do this because I'm a little bit sleepy like I've been telling you. decomposing once again. Excuse me. Okay, in that example, okay, you saw me be able to break up apart a few numbers. You saw, breaking up that 100 into 10 tens, and you also saw me break one of those tens into 10 ones. All right, let's get into the thousands now. Oops. Forget that. Running out of space here a little bit. 5,000. When you start working with those higher numbers, it does pay to be able to actually maybe make a check mark right there by the numbers you're working with. $3,120. Okay, remember these are the big cubes here, which equal 1,000. Take one from each side. 1,000 from each side. Okay. Cool. All right, so going back to our objective here is to visually represent a subtraction problem. Some kids are going to love this strategy. All right, so let's talk about this. The base 10. Okay, some things that I like about it, some pluses, are that, of course, it's visual. It also is good for place values. Breaking numbers apart is also good. And it also reaches all levels of learners. That's important. You know, as a teacher, you want to do that. Awesome. Okay, so let's go ahead and just do a quick review. All right, so once again, okay, the two different styles of thinking about subtraction are to find the difference, between the minimum and the maximum. We looked at the first example, which was called the counting up strategy. Okay, I like it because there's no borrowing. Great for your number sense. Excellent to be able to break the numbers up in certain ways. The next one was number lines. Remember that you can go forward or backwards with number lines. The next school of thought, of course, for subtraction is taking away. And we use the standard algorithm. And base 10. Of course, kids have to learn how to borrow with standard algorithm, and the base 10 is an excellent way to show a visual representation. Great for your number sense as well. Okay, and remember to have fun, work hard, and of course practice. 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 And in my case, I'll probably just say to get some rest. Get some sleep, Mr. M. But it's all good. Okay. I hope you got something out of that, and good luck practicing.